Most AI agents you see demoed online can't handle complex or long-running projects. They look impressive for simple jobs, but ask them to complete big tasks such as deep research, extended analysis, or to create comprehensive reports, and they tend to fall apart fast. The problem is that AI models have limited context, and most complex projects cannot be completed in a single context window. Anthropic recently published their solution to this, called an agent harness. It's a control layer or scaffolding for your AI agent that allows it to create a plan, save progress, and work towards a goal over time. In this video, I'll be diving deep into building agent harnesses in n8n. I've used this to create a long-running agent that can conduct deep research across lots of different data sources within a company at once. It can synthesize large amounts of data and then create and email a report to the user. There are many different use cases for this kind of framework. I'll be explaining exactly what an agent harness is, as well as multiple different patterns you can use to build them, which will make them applicable to practically any type of agent. For example, one kind of pattern will allow you to execute one task at a time, whereas you can use a concurrency pattern to execute many different tasks at rapid speed if that suits your use case. Agent harnesses can vary based on how tasks are planned, if there are any dependencies, and when a project is deemed to be complete. I put a lot of effort into researching this, so I'd really appreciate it if you gave this video a like and subscribe to our channel for more in-depth AI and n8n content. So let's take a step back. What exactly is an agent harness, and how do you build one? An agent harness is a control layer or scaffolding for your AI agent. So instead of just asking an agent to do everything at once, i.e. dragging in an n8n node onto your canvas and kind of expecting it to figure everything out, then we get a little bit more sophisticated and create a control layer around it where the agent can make a plan, can make many different tasks that it needs to execute that plan. It can save progress externally outside of the agent, such as in a file or a database. It'll be a database in this example, and then it can execute reliably over time. Before we go any further, let's take the following query, where we're asking an AI agent to create a Q4 quarterly customer review document for a particular customer. This, behind the scenes, would require a lot of research across lots of different data sources, unless you have all of that data pre-prepared for this exact type of query. It might need to process through lots of different meeting notes, transcripts, your database, your customer support knowledge base, and more. And when doing so, you need to separate the signal from the noise and make sure that you're extracting the most valuable information without overloading the context of the agent. Also, this question is time-based, so it's Q4 from a particular year, and it must be relevant to a particular customer. So this adds considerable challenges to the retrieval, and this is not just a single hop to a vector store. Clearly, a simple agent pattern is not going to work in this case. We need an agent harness. So let's walk through the flow of how this deep research agent harness works. I've taken inspiration from Anthropic's approach for this, where they're using a two-stage process, an initializer agent and a coding agent. Our use case is not a coding agent, but we still have similar steps, where we have the initializer step at the start and our step 2, which is our task harness. So the purpose of the initializer is to create an overall plan and all of the tasks associated with that particular plan. There are different approaches for this, and I'll be explaining all of that later, but let's just work off this example for now. In this case, we have this chat trigger at the very start of this stage 1 flow. The initializer step within this flow here is demonstrated in n8n right here within this part of the flow. So at the very start, we have this chat trigger, and I have a query here which is to create a Q4 quarterly customer review document for Global Tech, which is a customer in the database. Now, if I press enter on that, that's going to go to this input validation agent. So we want to make sure that it's all in the correct format and we have the correct requirements from the user before it continues along with the creation of the plan. So it has not yet created the plan. It's responded back to me to ask for clarifying questions to make sure it's on the right track. That's illustrated here. We ask the question, that goes to the agent, and before it does anything else, if more details or clarifications are required, it goes back to the user. And this loop continues on until this agent has validated and is satisfied that it has enough information to proceed. In my response here, I can just respond in natural language to these questions. So I'm going to say, yes, this is Q4 2025. And then for point number 2, what sections should this include? And I'll just say include all sections. What data sources should I use and prioritize? Point 4, what audience and format do you want? And from there, it should hopefully have the information it needs. to continue on and create the plan and all of the associated tasks with that job. So now it's done that, it's split it out, it looks like it's created 22 different tasks for that particular project. A project could contain many more tasks than that, but it's now updated that job to processing and it's executed the next stage of the workflow. So if I go back to this, you'll see that the agent has created the plan. Within that plan, it should have created a retrieval strategy, any summarization tasks that's required, and any writing or output tasks that are required at the end of the process. And then from there, it loads all of those into a database. That means that the agent can then pick off one task at a time. So when I go into the executions, we can see that the next task is now running. And when we wait for that to finish, it should kick off the next task after that. And there we go. This first task is complete. It looks like it's queried the database. It's moved on to the next task, where it looks like it has also queried the database for a different query, and it's going to continue on from there. So while that's processing, let's look at the database and see what exactly is happening there. Within the database, we have 3 different tables here. We have research jobs. For every one particular project or job, we have one record within this table here. And for any tasks related to that project, we have this planned tasks table. So there'll be one row for every single task required for that. And then we have research artifacts here. So as the agent is going through and trawling through lots of different data sources, it's going to synthesize and condense information from those and save them within this artifacts table. Later on, the summarization steps are going to condense those even further. And then the write article phase will then take information from this table and then create its final report and then send that to the user. So that's the overall schema that we have for this particular agent harness. You can get more complex than this for sure, but this is a pretty basic one that works quite well. Within this research jobs table, there's not a lot going on here. This is the output from the initializer first step, and the agent populated this field with this particular query. We have a little bit of extra context of what the agent needs to do and the current status of that particular project. We also have this locked at timestamp here, which is very useful to stop multiple workflows from picking up the same project at once. So as you see here, we have lots of different tasks created for this one particular job. And the real beauty of having this in SQL means that everything is transparent. You could store this in a JSON file, for example, or dump it within a JSON-B field within a database. But by actually creating separate tables within a database, it's very easy to track through each of these, and you have a pretty clear view of what exactly the agent is doing at any one time. So here we see for this particular job, the initializer agent created lots of different tasks. So it's created this database NLQ, so it's created 6 initial different tasks here to query different parts of the database. It's going to query the support system and get all of the support tickets required for that. It's also going to execute a hybrid search and look for information across transcripts and meeting notes, for example. Here we combine 4 different retrieval methods to try and get the most out of this retrieval as possible. Daniel goes through that in another video if you want to look at it, but it is included in the system. And we also have this concept of context expansion. We can use this feature to actually fetch the document hierarchy to select other chunks within the document or to retrieve the entire document itself. And we have the research artifacts table here. So as the agent is working through lots of data, it's using this database as its staging area. Later on, the synthesized tasks will be able to trawl through all of this and then process that as necessary. Now that you've seen what the database structure looks like, it should give you a much better idea of what I'm about to explain. So let's go back to our main workflow here. And within the first stage of this workflow, you see when it updates the job to processing after it's created the initial tasks, it executes the first task harness workflow. So it executes this sub workflow, which is down here. So every time one of these sub workflows is triggered, it's going to load the job and plan. So it's going to load that single record from the research jobs and try and find any remaining tasks associated with that job. From there, it loads the job, checks to see if that particular project is locked. And if it is, it stops the workflow. If it's not locked, and if that locked at field is not set, then we're going to go in and actually set the lock and set it to the current time. So until that lock is released, then another workflow will not be able to take on this project. From here, we're selecting the next task from the list. So that's a very simple select query. And if a task is remaining, we're going to route by the task type. So as you saw in the database, we have lots of different retrieval tasks, we have summarization tasks, and we have writing and consolidation tasks. So as those tasks are completed one by one execution of the sub workflow equals one task. It stores the artifact, marks that task as complete in the database, checks to see if there are remaining tasks left. And if there are remaining tasks, it goes all the way back up here, goes to the next task, and then goes through that process again and again and again. At the very end, it's going to check if there are remaining tasks and no tasks are remaining. Then it goes to a final job complete workflow that it's going to call. It will then consolidate all the outputs together and then send those via email. And you can do whatever else you want with it. So let's look at this within n8n. The next task is selected. We have a HTTP node here, which is going to get support tickets. So that could be interacting with any kind of support system, for example. We have this NLQ agent. And so NLQ stands for Natural Language Query. So this agent has visibility over our database schema, and it's able to execute SQL queries based on that schema. So there's data for it to query within the system. We have invoices, invoice lines, we have products, we have subscriptions, we have daily usage, for example, and the agent is able to construct SQL queries based on that. So if we go back to our database structure here, there are relationships between all these tables, and the NLQ agent would be able to construct these joins as necessary. You don't have to give your agent full access to your schema. There are lots of different approaches you can use. I recently released a database agents video where I go through this in detail. There are lots of different approaches you can use for your agent to actually interact with your database. You don't need to give it full access. For example, even if you're using read-only, you can give it access to specific queries, for example, and parameterize those so you really lock down control over what it has access to. You can use whatever approach you want, but this is an example where we're giving it access to execute SQL queries against that database. So in terms of retrieval, you could have lots of different routes there. You could interact with other systems. You could just stack these on top of each other. And when you're doing that, just make sure to update this planning agent up here and give it additional context of what tools it actually has access to. That will get it in the best position to be able to create the correct plan up front. And for these last two task types, we have a synthesize route and the write report route. So within this SQL query, we're getting back all of the research artifacts that are not of type synthesize and not of type write report. So we're basically getting everything back that we got previously here. So then after that, we have a loop over items. We want to make sure we're not overloading this synthesize agent with context. We're only giving it 10 research artifacts at a time. Then it's going to synthesize those as necessary. And here I'm asking it to synthesize the information. When tables and figures are provided, try to include those within the summary when possible. If there are any contradictions or conflicts between information provided, try to highlight that as well and list all the sources in the output. So we'll have a synthesized view of all of those research artifacts as well as the sources in a separate field. And it's going to go through that multiple times. Potentially, if there's lots of different research artifacts, then it's going to aggregate all of that together and store it within another research artifact in the database. So as I've been explaining all of this, it looks like it's gone through every single one of those tasks and marked them as complete. So that means it's also gone through to write the report. So if we examine exactly what it did there, let's copy that to editor and mark it as unpinned. If we go down to that part of the flow, it's picked up the first write report task within this job. It's getting the previously summarized items. It's then aggregating those together. It's also getting the previously written items if they are present. And then it's aggregating those and then loading those as context into the agent. So if we look at the prompt here, we have the section that it needs to write. We have all the previous research artifacts, and we have any previous content that was written. There's lots of different ways that you can manage context across an agent like this. You could use progressive summarization, for example. You could pass in the previously written sections, but then have more rolled up summaries of other sections and other parts of the document up until now. It all depends on how complex your document is. If it's possible to pass in the whole context of the document as you're writing it, that can work very, very well. But if you have large projects, that's not always an option. So the approach here very much depends on your use case. I'll be talking about other patterns and use cases later on in the video. So we're finally storing the report output. That's stored as another research artifact within this, and that goes back, removes a lock, and then executes the next worker. However, in this case, all tasks are complete, so it's now finally executed this final completion workflow where it should complete the job. So at the end of this process, I've received an email with this particular report, so I'm going to open that up, and we can see a full executive summary. And now we see the entire report here. We have synthesized information across a lot of different pieces of data. Further down here, you see we have all of the support items relevant to this particular customer. It's highlighting these higher up in the document. We see some of the data has been synthesized with customer meeting notes and transcripts, for example, to give a higher level view of some of that more unstructured information. And we also have quantitative information here, which would have been gathered from the database. Letting your agents access and query structured information at scale using SQL either through arbitrary SQL queries or through more locked down parameterized queries. Those approaches are extremely powerful and incredibly underrated, and they can really add a lot of value to these kinds of agents. So at the very end of this process, it hit this completion trigger, and that's another sub-workflow. It updates the job to completed within the database. It retrieves all of the written outputs that the agent created throughout the process, which is in this write report task status. And then those are all created in order. So we just need to concatenate those together. We use a summarize node here. Then we use a basic LLM chain here just to provide a file name for the report, as well as a title for the report to appear in a H1 heading. This could also definitely be within the initializer phase as well if you want. Then you can use whatever approach you want to deliver that particular file. In this case, I got AI to convert Markdown to HTML, and then that converts it to a HTML file. I then change the MIME type to text HTML, and then I just attach that as part of an email. You could also get the agent to actually just generate in HTML as well. That means you don't need to go through that process of converting to Markdown. There's also a HTML to Markdown node within n8n. I found it was not converting the tables as required here fully, so I ended up just coding my own node for that. But really, once you have the document in a Markdown format, you can use whatever service you want. There's plenty of libraries, there's plenty of external APIs. You could create PDFs or docx files, for example, upload them to Google Drive or whatever you want. You could also add a lot more feedback throughout this process. For example, you could add in a Telegram or WhatsApp trigger at the very end of this process within this task worker harness part of the workflow. That means that every time a task is completed, it could send a notification. Or you could get less granular than that, for example. If you have lots and lots of tasks, then that could overload your notifications a little bit. So this kind of workflow could potentially run for many, many hours. The planning agent here could create hundreds of different tasks, and then they're worked through one by one. But this particular deep research workflow could lend itself well to a concurrency pattern. So let's have a quick look at that. Within our RAG at scale video, I explained a pattern that you can use to ingest very large amounts of files in quick succession. We can batch many files at once, for example, 50 or 100 files, and then quickly call this ingestion workflow in very quick succession. That means you can have many workflows executing in parallel. This HTTP call is hitting a webhook within this RAG at scale ingestion workflow. And for every file that's processed through this, it goes through the entire process. But the same kind of process could apply to this kind of agent harness system as well. So let's go back to how we would adapt this kind of agent harness system to use a concurrent retrieval orchestration flow. So if we look at this, when the task harness is hit to get the next task, it will route by the task type. If there is a retrieval task left, it could hit a retrieval orchestrator workflow, which then will process all of those in batches. So then it will get lots of different tasks and then retrieve the data as it needs to. So this is a very similar pattern that we use in this. We'd have a separate retrieval orchestrator that would call a separate workflow for every single task that needs to be processed, and it will then work through all of those as necessary. In our RAG at scale system, we also had a catch-all error handler and automatic retries. So you can get quite sophisticated with this and really build quite a resilient system. So as this retrieval orchestrator is called, it gets the available retrieval tasks required. It processes those in parallel. It makes use of n8n's queue mode and makes use of multiple workers to make much better use of your resources. It will then mark all those retrieval tasks as complete. We then go back to the database, check are there any other remaining tasks, and when there are, it'll go back, route by task type, and then go through the regular part of the flow that we already explained. The regular parts of the flow would be synthesize and write article at the very end here. So this kind of approach I'm explaining here, where we're using this retrieval orchestrator, will be seen as a kind of a hybrid concurrent approach, where we're only using concurrency on the retrieval aspects, but on the summarization tasks and writing and consolidating, you may need to do those and execute those sequentially. Your agent harness can be created specific to your use case. Again, this works in parallel. The writing and consolidating may not work in parallel. You need to create the system to work for your particular job. So before we go through different types of agent harness patterns, I'd like you to ask yourself, is this a new game-changing concept for creating AI agent systems? An agent harness is a great umbrella term to describe that you need to architect your systems to have an extra layer of sophistication outside of just relying on the LLM directly. And Anthropic here really are just popularizing and raising awareness of an already existing concept, while also giving specific implementation details as well as a quick start repo that you can work from. In many ways, AI engineers have been building systems like this for a very long time, especially in the early days where LLM context windows were extremely low. It's only relatively recently that we've started to rely on agents to do a lot more, that as context windows have increased, you can fit a lot more in. The intelligence of the models have improved. But in fairness to Anthropic, they really are admitting here that we cannot just throw away the scaffolding and rely on the AI agents themselves, especially when it comes to more complex or long-running tasks. And Anthropic's approach here is just one way to build an agent harness. It's very much grounded in the coding context. There are lots of other ways, and that's exactly what I'm going to go through now. I'm going to ask you 5 different questions that you should ask yourself when you're thinking about creating an agent harness, because that could really affect the architecture of the system and the success of the output. So the first is about persistence and memory. Agent harnesses are all about memory outside of the agent. It's storing that memory in a particular place. Are you storing it in a file, such as a JSON file, or in a database? You could store it in an n8n data table, for example, if that fits your use case. Within this state memory, you're effectively defining what the schema is in your database and how you will be populating that. And if you're using JSON, then the same would apply to your JSON structure. You have one job, you have multiple tasks, you have statuses. So this is the core part of your scaffolding. After that, you have your artifact memory. How are you storing your outputs? Are you processing your outputs? Are you processing summaries? How are you going to piece them all together? You have compressed memory. So what we still need to remember, we have progressive summarization. So as the work goes on, older tasks get compressed more in comparison to the newer ones. The agent can also take periodic snapshots of the state of work as it is. And then if the agent gets confused, it can look back at previous snapshots. We also have high-level plan summaries. So similar to how we created a plan within our workflow, the agent can reference that plan and know exactly where it is in the overall context. You can also keep track of historical memory in your data structure. So what particular events unfolded to the current state. We technically have a view of this within our own data structures, but you can get a lot more granular with that, have audit logging trails and execution logs, for example. You can also have checkpoints, so you can periodically save the current state of your data, and that means you can quickly roll back to that as necessary. As you see, the persistence and memory varies a lot based on the use case. These are not all relevant to a deep research use case, for example, but these kind of questions can help you get a little bit more granular based on the exact use case you're working off. The next question is, how is work broken down and updated over time? Within this video, the initiator section of this workflow executed a plan at the very start. This is effectively a static plan. It creates lots of different tasks, and then the task worker harness will be used to execute those one by one. But you could also have a rolling plan. You could start with an initial planning stage, execute based on that, and then reevaluate and then replan to see what the next course of action is. You could also have a goal-driven plan where the agent will constantly ask itself what the next best course of action is to achieve that goal. You really would need some guardrails and logic within that to stop your agent from just going in an infinite loop or kind of going off track. And then finally, we have this test-driven loop. So you iterate until criteria is met. For your use case, if it's possible to actually test the outputs and then add that in as a feedback loop into your agent, that can be really, really powerful. And it's one of the reasons why AI coding tools can be so successful, because they can execute the code, check the results, and then update based on what those results were. So you could have automated testing in a test-driven loop here, or even human in the loop could be part of the process, where the agent would wait for feedback from the user and then decide how to progress from there. The next question is, how are tasks actually run? You could have one single continuous execution in one long-lived control loop. That's partly what's happening within this workflow, except we've broken this up into different executions within n8n. You could have all of this within one big loop in a workflow. If you're persisting those correctly to a database, you could potentially be able to automatically recover and retry in the event of a failure later on. So one particular workflow could even work. You can run into out-of-memory errors, so that's also an issue too. By using separate sub-workflows here, that really mitigates that issue. And you can also have lots of other good stuff like task concurrency as well. You also have to decide, when is the work complete? Are you going to work through the entire plan? Are there certain rules you have in your workflow that will define when the job is complete? Is the LLM going to critique or judge it? You could use a similar approach to our verify answer feedback loop that Daniel goes through in our RAG patterns video for this, and then expand that out as you need. You could have a check that tests must pass, and Claude uses this within their coding agent, which is a really good one because by actually having specific criteria that it needs to pass, and as an external way to test that, then it stops the LLM from declaring success way too early on in the process. And again, this is the beauty of the agent harness idea. We're not just relying fully on the LLM. We have some other criteria, some other scaffold beyond the LLM itself to define when that work is complete. And another stop condition is human in the loop. For example, you could have a Telegram trigger, an email trigger, and the response to that could dictate when the job is actually complete. And finally, how many units of work can run at the same time? And are there any dependencies? Coordination and concurrency is a really big part of agent harnesses. In the example I went through, we have sequential ordered steps, so you work through your plan. We have parallel, where you're going to execute many tasks at once. And we have hybrid, where you have parallel and then synthesize the results. And that's exactly what I went through within this long-running deep research example with concurrency, where you're going to process all the retrieval in parallel, but then synthesize and write more sequentially because they should not be processed necessarily in parallel. And then you have a dependency graph, which can be very powerful and really represents some pretty complex relationships between tasks. Let's go back to our tasks table. So we have our sequence order that we want these to execute in, but you could also have dependencies represented between tasks. Those can be represented in a JSON-B field. You could also have a separate table within your database. This would be one of the easiest ways to actually implement this within n8n. So you would have a separate dependency table. So one task here could be related to other tasks. So it could have child tasks or it could have parent tasks, for example, and you could represent that however way you want. There are many cases where more standard agentic patterns will work for your use case, and that's completely fine. But if you find yourself needing more durable memory across executions, if you need to resume after failure, if you want more transparency and observability over the tasks that are being completed within the workflow, if you want better cost efficiency, potentially, if you can really control how data is flowing throughout your workflow, and if you want your agent to be able to run for long periods of time, then an agent harness is often going to be the best approach. If you understand how to build agent harnesses, you're generally going to be way, way ahead of most other people building AI agents. And they allow you to build far more complex, sophisticated, and long-running AI agents that actually get real work done. If you want to get access to everything I went through in this video, and check out the link in the description to our community, the AI Automators. If you found this video useful, you're going to love our step-by-step walkthrough of deploying a fully private and local AI RAG agent, linked in the card above.